Hi, intermediate algebra students. Today we are going to move on to section 9.3, where we're going to learn how to rewrite radical expressions. Now, this lesson is a skill-based lesson, so we're basically going to learn a skill that we will need to use in section 9.4. To get started today, first we want to talk about what does it mean to take a square root? Well, in order to do that, we need to understand what a square root looks like. Now remember, this symbol is called a radical. Just a fun fact, the thing that's under the radical will be called the radicand. Every once in a while, Pearson uses that language, so I just want to make sure you know what that is. And last but not least, the other important thing about a radical is that sometimes there's a number in this spot right here in the little v. That number is called the index, but many times there's also no number there. And if there is no number, it is a 2. Okay, because it's called the square root. So in this chapter, we're going to focus on square roots, but as we move ahead in math, we will start seeing other numbers there. Okay, so there won't be a number there this chapter. That is called a square root. Now, what does it mean to take a square root? Well, if I had, for example, the square root of 4, okay, it's kind of about thinking about exponents backwards. If I want to know what the square root of 4 is, I'm asking myself, what times itself 2 times is 4. And again, the reason 2 times is because the index is 2. Okay, so you're thinking about this, what times itself, this number of times gives you the radicand underneath. And we're going to use that idea as we simplify today. Okay, so the first thing you're going to have to be able to do is compare two different roots. So you're going to take something that looks like this, the square root of 20, and you're going to describe how it compares to something like 2 root 5. Now you could just type them into your calculator and see what the decimal is, but we're going to see algebraically how we can simplify the square root of 20 to see what it looks like compared to 2 root 5. In order to do this simplifying today, we need to understand one property. It's called the product property of square roots. What it says is that if we have two things times itself under a radical, so like the square root of a times b, we are allowed to break that apart as two independent radicals, so the square root of a times the square root of b. Now again, it's important that they have the same home, which would be the same type of radical. So since it started as a square root, when I break it apart, both of these must be square roots. It's also important to remember that when we have equal signs, they work both ways. So if I ever had a square root of a times square root of b, I would be allowed to put it together as the square root of a times b. It works both ways. For our purposes, we're mostly going to start with a single radical and think about what it would happen if we broke it apart as 2. Now, one important fact when we're dealing with square roots is that the radicands underneath must be positive or 0. So a and b must be greater than or equal to 0. We cannot take the square root of negative numbers. And that's going to be important not only today, but tomorrow as well in 9.4. Okay, so if we want to simplify the square root of 20, we want to break it apart as two things, the square root of something times the square root of something, and hope that one of them is a perfect square. What I mean by that, when I think about 20, again, you don't have to list these out, but the factor pairs of 20 are 1 and 20, 2 and 10, 4 and 5, those are it. What I'm doing is I'm looking for these at these lists to find which ones are perfect squares. Now, some perfect square roots, these you might want to get in your notes just to make sure that you understand them. The square root of 1 is obviously 1, but that's not going to help me ever. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Could keep going. We should know that the square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9, and the square root of 100 is 10. The better you know this list of numbers, or the list of relationships, the easier this is going to be, because now I am looking at the 4. And I recognize that if I change the square root of 20, the square root of 4 times 5, okay, now I've made it look like this, then I can break it apart as the square root of 4 times the square root of 5. And as my list shows here, the square root of 4 is 2, because I know 2 times 2 is 4. So this is the same as 2 times the square root of 5. So when I simplify square root of 20, I get 2 root 5. Well, it asks me to compare it to 2 root 5. They're actually the same thing. And by simplifying, I was able to show that. But this process of taking a radical and simplifying it is really the main concept of today. Let's look at a few more examples. The first one says compare the square root of 36 and 3 root 6. Now, I always take the one that's not simplified. So I'm going to take the square root of 36. As we just showed, hopefully you know that the square root of 36 is just 6. But let's talk about why. Here's another thing you're going to want to know when you're simplifying. If I was thinking of two things that multiply to 36, I could break this apart as the square root of 6 times 6. Another thing you're going to want to know as you're looking at these is if you're taking a square root, again, we're looking for two things times itself to equal what we started with. Now, if you're ever breaking it apart and you end up with two of the exact same number under a radical, the square root of 6 times 6 is just 6. Okay, you don't need to show this work here. Again, hopefully you just know that the square root of 36 is 6, but that idea that I had two 6's times itself under the square root symbol and I could take the 6 out, that is going to be important when we get to more complex problems. All right, so the square root of 36 is just 6. Having said that, it is not the same, so it's different than 3 root 6. So sometimes if they ask you to compare, they're really just looking for, is it the same or different? So in number 2, we're going to take the square root of 72. We're going to simplify it and see if it's the same or different as 6 root 2. So go ahead and pause the video and see if you understand kind of what we're talking about. Now, we've only done a single example, so you might still be stumped. So if you're stumped, just keep playing the video and watch me walk through another one. All right, so when I think of 72, I'm going to think of different factor pairs. And again, there's different ways you can think about this. When I think of 72, I know it's 1 times 72, but I'm never going to use the 1 as my main option. If I do 72 divided by 2, it's 2 times 36. I could keep going. It's 3 times 24, 4 times 18, 6 times 12, and 8 times 9. Okay? Remember, I'm looking for those perfect squares. Having said that, I would have stopped right here because I see the 36, and I know the 36 is a perfect square. So when I rewrote this, I rewrote it as the square root of 36 times 2, which means I can rewrite it as the square root of 36 times the square root of 2. And I know the square root of 36 is 6. So this is 6 root 2. They wanted me to compare it to 6 root 2, so these ones are the same. Now, I want to show you just what would happen if you're like, well, you know, I looked at that list, but I actually thought, when I think 72, I think 8 times 9 first. And 9 is also on that list of perfect squares. There's multiple ways you can get to the same answer. So if I had chosen to do the square root of 9 times 8, here's where you have to be a little careful. Because yes, the square root of 9 is 3, but when I have times the square root of 8, I can keep going. So the square root of 9 is 3, but 8 is the square root of 4 times 2. Okay, so you can't stop if you still can break apart numbers under the radical. So now I would keep going. I can break apart root 4 times root 2. And now I still have my 3 in front, but the square root of 4 is 2. If you have more than one thing, you would multiply those together times the square root of 2, and 3 times 2 is 6 root 2. So you can see, even though I started in a different spot, I got to the same answer. It did take a little more work. So if you find a perfect square, but it's not the biggest perfect square, it's just going to take you an extra step. Okay, so this is comparing, but the rest of the lesson is the same idea, because now it's going to just say what's an equivalent expression. So we're not comparing it to anything, but we are just going to simplify. So if I'm asked for an equivalent expression of 63, Again, I'm thinking of what two numbers multiply together to get to 63. And right away, I know that it's 9 times 7. And I'm thinking about that list of perfect squares. So hopefully you wrote those down at the beginning. If you didn't, make sure you go back and pause the video at that slide to make sure you write it down. It's also on the note sheet that I'll show at the end. Okay, so as soon as I see root 9 times 7, I break it apart as square root of 9 times the square root of 7. Square root of 9 is 3. So this simplifies to 3 root 7. Okay, now that we've done a lot of examples, I want you to pause the video and try both of these on your own. So the first one's pretty straightforward from what we've been doing. I see the square root of 44, and I thought of 4 times 11. So I rewrote it as the square root of 4 times the square root of 11. And I can break it apart as the square root of 4 times the square root of 11. Square root of 4 is 2. Root 11 is as simple as it gets. That's my answer there. Now, number 2, there is a twist there. I purposefully wanted you to see if you could find the twist when you did it, but let's take a look. This one's different because it has a number in front. If there's already a number in front, you still just keep it there. So I'm going to bring the 3 down, and then I'm going to think about 27. 27 I know is 9 times 3. So again, I would keep bringing it down 3 times. I break it apart, square root 9, square root 3. Bring this 3 down. Square root of 9 is 3. And we already talked today in the previous example where if you have multiple things, you just multiply them in front, and then the square root 3 is as simple as I get. Now I multiply these out, and I get 9 root 3. Okay, so you might have needed some help on that since it was a little bit higher level problem from what we did in the previous ones. Hopefully that cleans it up for you. And last but not least, let's take one more step. Following these same ideas, every once in a while, you're going to start with 2 radicals multiplied times each other. Now remember, we did write down at the beginning the square root of a times b is the same as the square root of a times the square root of b. And we said we need to make sure it goes both ways. These problems, the higher level ones, will be where you're given more than 1 square root times each other. So you will actually want to combine it as 1 square root. So if I have 3 square root 5 times 2 square root 15, one thing I always do is those numbers in front, the 3 and the 2, because it's all multiplication, I move those to the front. Okay? You wouldn't have to rewrite this as the square root 5 times square root 15. But if you do, then the 3 times 2 is 6. Now, here's one thing. I understand that I can now put them together under 1 radical. So I'm going to write it as the square root of 5 times 15. Now this is where you have choices. You could do 5 times 15, and then you would break that number apart. But one strategy that I use to make it a little more quick is remember when we had the square root of 36. I said understanding that it was the square root of 6 times 6 is going to be helpful for the future. It's for problems like these. If you can make it so that you have 2 numbers times each other under a square root, those get to come outside as just 6. The reason I say that is because I'm actually going to keep this first 5 just as a 5. But then I'm going to break apart 15. And I know 15 is 5 times 3. Okay, so this 15 became 5 times 3. This 5 just stayed 5. And the reason I do this is because now using this strategy that I showed up here, I now have 2 5s under the radical. So they're going to come outside. The root 3 stays underneath. So 6 times 5 is 30 root 3. Okay, so it's when you're multiplying radicals together that rather than making it more complicated from the beginning, okay, so rather than doing 5 times 15 and getting 75, I just kept it separate. Now you could have from here, just to show you, 6 root 5 times 15. I could have done 5 root 75. Okay, now if I did it this way, I would know that 75 is 25 divided by 3, or 25 times 3, I mean. I would have done 6 times root 25 times root 3. Root 25 is 5. I get the same thing either way. And again, both strategies work. You're free to do either one. But depending on how big these numbers are, this part could take you way longer in the end. If you understand the idea that you can get 2 things times each other and then take them outside, Because right now I see if I multiply those, it's 25. So that's why the square root of 12 is 5. All right, let's try one more. We're going to do one more together. If you're feeling good, you can pause it and do both on your own, but let's do the first one together in case you're confused. All right, so I see multiplication. So first I do the 1/2 times 4. Now I'm going to, in this step, do 21 times 7. Okay, so last time I broke that into 2 steps. Next, I'm going to do the 1/2 times 4. Half of 4 is 2. And I'm going to break apart the 21 for now. And I know 21 is 3 times 7. So rather than multiplying those together, and then don't forget to bring down your 7. So this is the 21. This is the 7 brought down. You see 2 7s under the radical. So they go outside with the 2. I have 2 times 7 root 3, which is 14 root 3. Okay, so if you needed help and you wanted to see one more example, there you go. But now I need everybody to pause the video and try number 2 on your own. Okay, this time there was no number in front of the second one, so I just have a 2 in front times the square root of 12 times 18. Again, if I multiply 12 and 18 together, I get a really big number that I have to break apart anyways. So instead, I'm going to start by thinking about 12 and 18. Now 12 is 1 times 12, 2 times 6, or 3 times 4. I could, in theory, break it apart to any of them. But remember, we want to compare it to 18, which is 1 times 18, 2 times 9, 3 times 6. Okay. It doesn't really matter which one you go with, but I'm looking for any of these that have pairs. So for me, first, I started with these two because they both had a 3. So I did the 12 is 4 times 3, the 18 is 3 times 6, because I right away saw these that were the same. Now, there could be a more efficient way. So I have 2 times 3, the 3 comes out. Technically, I have the square root of 4 times the square root of 6 left. Well, I also know that the square root of 4 is 2 times root 6. And now I do 2 times 3, which is 6, times 2, which is 12, and I'm left with 12 root 6. Again, you may have gone in a different order. You may have seen something different. But for me, that's the way I process through. So as you can see from 6.3, really we're focusing on understanding what a radical expression is. It's a square root. We need to make sure we know this property, where if we have the square root of 2 things times each other, we can break it apart, and vice versa. And then finally, we're just focusing on simplifying radicals with numbers, like the first example we did, and then finally with multiplying 2 radicals together, 2 square roots. Okay, here's a copy of the note sheet. It's also in your Schoology folder if it's hard to read on here, but make sure you have all this information. And again, these perfect squares are really good to know. Go ahead and work on your Pearson practice or wait until after the warm-up tomorrow, but hopefully you'll have a general idea of how to do these. Thanks.